In this video, we're going to discuss the expected value and standard deviation of a probability distribution. So in the last video, we learned about probability distribution functions, or PDFs, and we can calculate means and standard deviations, or measures of spread, for these distributions, just like we would for a distribution of raw data. You're going to see a new term here, expected value. And expected value, which is also known as the mean, when we're talking about probability distributions, specifically this is the long-term average over many trials. So if I'm talking about that probability distribution we built in our last video of flipping 3 coins, if I wanted to find the mean of that, I'm finding the long-term average if I flipped a coin 3 times over and over and over again until I was so bored I couldn't stand it. The average outcome, the number of heads I get on an average 3-coin flip, would then be the long-term average over all of those trials. The standard deviation measures the spread for that random variable. And we have formulas for these that I'm going to write off to the side. So for the expected value, we write E of x. You'll also see that sometimes written as mu. And for the standard deviation, we're going to use, sigma, which is the symbol for standard deviation. For the mean, it is the sum of all of the values of the random variable times their probabilities. Looking at a PDF, a probability distribution function, we multiply across the rows, and then we add down that new column. For the standard deviation, we're going to take the sum, and this is going to be messy, so I am going to apologize, of x minus the mean squared times the probability, and then all of that gets thrown under a square root. And I'm not terribly surprised to see a square root here, because we know when we calculate standard deviation for raw data, we also see a square root. These calculations aren't too terrible if you have a probability distribution function in table form, but they can get tedious very quickly. So on the TI-84, you're going to put your x values into list 1. You're going to put your p of x's in list 2. And then you are going to run one var stats on list 1, list 2. So when you pull up one var stats, that's the list. This is the frequency list. We're going to do an example with the calculator so you can see how this works, and then I'll set you free to try some on your own. So for this example, we're going to go back to the PDF we constructed for a flip of a coin 3 times. And so we may remember, if I'm counting the number of heads, I could have 0, 1, 2, or 3. And I know that the probability was 1/8, 3/8, 3/8, 1/8. So on our calculator, I am going to put these values in list 1 and these values in list 2. So let's go ahead and pull up our calculator somewhere. So stat, enter, and my x values are 0, 1, 2, 3. My p of x values are 1/8, 3/8, 3/8, 1/8. And then I want to run 1var stats. So stat, calc, 1var stats, L1, and then my frequency list should be L2. And if I scroll up, you'll see X bar. We know that's the symbol for the mean, so that's our expected value or mean, 1.5, which is exactly what we saw from the graph in our last video. And then I can see a standard deviation sigma x of 0.866. You'll notice this output does not have a value for Sx. Your calculator will recognize that what you just put in that data table is a probability distribution that represents an entire sampling space. And since it represents the entire sample space, we know that it is population data. And so it shouldn't have an Sx, it's only sigma x. So 1.5 and 0.866. If I wanted to do this in table form, I'm going to scoochie these values over, I would add 2 more columns to my table. So the 2 columns that I would add here are going to be a column for x times p of x, because I know my mean is x times p of x. And then I'm going to add a column for x minus the mean squared times p of x. Is those 2 things, if I add them up, those help me calculate the mean and standard deviation. So for x times p of x, I'm just multiplying across this column. So 0 times anything is 0, 1 times anything is itself, 2 times 3/8 is going to be 6/8, and 3 times 1/8 is going to be 3/8. I'm going to add down, and that's going to give me my mean. So 3 plus 6 is 9, plus 3 is 12. So this is 12/8. And I know that 8 goes into 12 one time and leaves 4 left over. And 4 over 8 is 1 over 2. So this is 1.5 or 1.5, which is good news. That's exactly what we saw with our calculator. For x minus the mean squared, I'm going to leave mu as this, because when I'm subtracting from x, notice that all of my x's are in terms of eighths. Leaving this as an eighth will make it easier. So I'm going to do 1/8 minus 12/8. No, 0 minus 12/8. Oh my gosh. I did that wrong. I'm doing it minus that. So let's do the 1.5. 0 minus 1.5 is minus 1.5 squared times 1/8. And then 1 minus 1.5 is negative 0.5 squared times 3/8. And then I get 2 minus 0.5, which is 0.5 squared, times 3/8. And then 3 minus 1.5 is 1.5 squared, times 1/8. So I'm going to do that all at once on my calculator. And this is going to be the sum of x minus mu squared times p of x, which is not quite our standard deviation. But let's grab a calculator and do that sum really quick. Or not really quick, as the case may be. So 1.5 squared times 1/8 plus 0.5 squared times 3/8 plus 0.5 squared times 3/8 plus 1.5 squared times 1/8. And assuming I did that correctly, I got Did I do that correctly? I got 10.0. That doesn't feel right to me. Oh, I missed a decimal point. Mr. J. I'm sorry about that. I missed a decimal point. Let's try this again. And thank you for your patience. Oh, I did it again. Oh my gosh. Oh, let's do it on a fancy calculator and see if we can do it faster. So 0.5 squared times 1/8 plus 1.5. Ooh, no, not that. Okay, 1.5 squared times 1/8 plus 0.5 squared times 3/8 plus 0.5 squared times 3/8 plus 1.5 squared times 1/8. 0.75, that's more promising. So we get 0.75. And I know that my standard deviation is going to be the square root of that sum. So we're going to go back to our calculator. We want the square root of 0.75. And we get 0.866, which is convenient because that is exactly what the TI-86 gave us, or TI-85-4 gave us, I can't count today, when we ran 1var stats. So as long as you're careful with your typing, using the formulas should give you exactly the same answer as 1var stats. It is important when you do it on your calculator that you make sure the x's and p of x's line up exactly like they do in your original PDF. That is super important. If you have any questions on expected value or standard deviation for probability distributions, feel free to send me an email. Otherwise, I will see you in our next video.